Hi, in this video, I am going to discuss on monotonic sequences. A sequence AN is said to be monotonic if any of the following two conditions satisfies. First, if the term AN is less than to its next term is less than or equal to its next term AN plus 1 for all n element of natural numbers, then the sequence is monotonically increasing. Now we can verify this inequality if we are able to show that this inequality AN minus AN plus 1 is less than or equal to 0 holds. On the other hand, if the term AN is greater than or equal to its next term AN plus 1 for all n element of natural numbers, then the sequence is monotonically decreasing. Again, we can verify this inequality if we are able to show that this inequality AN minus AN plus 1 is greater than or equal to 0 holds. If both the first and second conditions satisfied simultaneously, the sequence is called constant sequence. That is, AN is equal to AN plus 1 for all n element of natural numbers. Example, the sequence 3, that means that all the sequence terms is 3. Okay, example number 1, determine if the given sequence is monotonically increasing or decreasing. Number 1 given is the sequence 1 over n. Now, if we are going to write the elements of the sequence 1 over n, it can be written as n equals to 1. This means that if n is equals to 1, the sequence term or the first term is 1. And then if n is 2, the next sequence term is 1/2. And if n is equals to 3, our third sequence term is 1/3. And the fourth sequence term, if n is equals to 4, the fourth sequence term is 1/4. Now, if you are going to observe, okay, these are the first 4 terms of the sequence 1 over n. And then the rest, we have dot, dot, dot. Okay, 3 triple dots. Now, if you will observe, from 1 over 1 or 1, our second term or the next term of 1 is 1/2. Then from 1/2, the next term to it is 1/3. Then from 1/3, the next term to it is 1/4. Now if 1 over n is 1 over 1, the next term to it is 1/2. And we can say that if 1 over 1 is 1n, 1/2 we can write it as 1 over n plus 1. Now if 1/2 is 1 over n, the next term to it, which is 1/3, can be written as 1 over n plus 1. Simply because from 2, we will add 1. If 2 is n, for 2 becomes 3, we simply add 1 to n. And then 1/3, if 1/3 is 1n, then we can write 1/4 as 1 over n plus 1. This is because if 3 is n, then 4 can be written as n plus 1. Then, we can say that for the rest of the sequence term under the sequence 1 over n, we can write it in this way. 1n, and then the next term to it is 1 over n plus 1. Now, if we are going to observe, the first term, which is 1, is greater than 1/2. Then 1/2 is greater than to its next term. Then 1/3 is greater than to its next term. This means that the elements, the value of the sequence term or the elements of the sequence decreases as n increases. Remember that our n here are the number of terms. So if n is 1, we have 1 as the sequence term, the first term. And then for the second term is 1/2. For the third term, we have 1 over 3. Now the elements decreases, the value of the elements decreases as n increases. Hence, in general, we can say that 1 over n is greater than or equal to its next term, which is 1 over n plus 1. Take note that if we are going to apply the previous definition for monotonic sequences, we can say that 1 over n is our an, and 1 over n plus 1 is our an plus 1. Now, to identify or to determine or to verify that the inequality holds, we can equate the inequality into 0. So that is 1n minus 1 over n plus 1. To simplify, we have this one in which n times n plus 1 is our denominator. And then, to simplify further, we have this inequality in which we cancel out n here because n minus n is equal to 0. Now, to determine if this inequality holds, we will substitute some values for n. Now, if n is 1, this value here is greater than 0. If n is 2, still the value is greater than to 0. And if the value is more than 3, or the value of n will be from 3 to positive infinity, still the value of the entire expression 1 over n times n plus 1 is greater than 0. Therefore, from this definition, we can say that the sequence 1 over n is monotonically decreasing.